and here I'm back solving the various different type of differential equation. In chapter 9.3 we'll be dealing with how to form a differential equation by eliminating the arbitrary constants. Since constants are normally not mentioned, but here these constants are mentioned, and these arbitrary constants sometimes are also called the parameters of the equations. So we have to form a differential equation by eliminating the arbitrary constants. So just without wasting your time, let me get back to the questions directly. So the first question is that equation is x over a plus y over b is 1, and then we have to find the differential equation by removing these parameters or these arbitrary constants a and b. So how do we do that? So first we have to differentiate it. So right here, differentiating both sides with respect to x. Okay, so this is x. So what you get? 1 over a, because differentiation of x is 1, plus y, this is dy by dx into 1 by b is 1. Okay, now we have to differentiate it one more time. Then what do we have? This is constant, so the differentiating right here, differentiating again both sides with respect to x. So what you get? 0 here, plus 1 by b is just constant, and if you differentiate dy by dx with respect to x again, what you get? d2y or d square y over dx square, and this part is 1, so differentiation of this one is 0. So what we have? We have 1 by b d square y by dx square is 0, or d square y by dx square is 0. This is our differential equation corresponding to this particular equation by removing the arbitrary constant a and b. So your answer is d square y over dx square is 0. Example. Now we have our differential equation. We have to derive the differential equation by eliminating the variable a and b, and from this equation, which is y square is a b square minus x square. So now I differentiate. So what is differentiation of? So right, differentiating both sides with respect to x. So differentiation of y square will become 2y dy over dx, and here it's a is constant, so this is done, and differentiation of b square is 0 minus this is 2x. So what do we have? Minus 2ax, and this is 2y dy over dx. This 2 cancel, so y dy over dx is minus ax. Now I have to differentiate this whole thing again, but this is now treated as uv. So what do we do that? So we write y unchanged, differentiation of dy over dx, that is d square y over dx square, plus dy by dx unchanged, and differentiation of y is dy over dx, and this differentiation of x will become 1, that is minus a. So we have our equation like this, this, and then how we can solve this? So we have to solve this by eliminating this variable. So now how can we eliminate this part? So you see that here this relation that we have, let me draw a line here. So this is, we found y dy by dx is minus ax. So at the place of minus a, if I write this whole thing, then what will become? So here I solve this expression slowly. I will not be speaking anything, and then you just keep eyes on what I am doing this. So y dy by dx at the place y minus a. So this हाँ कर दो, वहाँ से तो हटा देना है।
ठीक है ठीक है।
डी स्क्वायर बाई डी एक्स स्क्वायर प्लस हाँ नीचे की तरफ थोड़ा झुका देगा, नहीं दिख रहा है तो।
हाँ दिखा, हाँ। तो अब जो हम लोग ये बोल रहे सब कुछ वॉइस ही निकाल देना है। ठीक है, समझ में आ गया।
अब pause कर. So here I found the value of minus a as this, and then I simply in this equation here, in this equation I just put the value of minus a. So y dy by dx, y dy by dx is, this is all is minus a and this is x. Then I simplified and I found this is the answer. So this is your differential equation we found by removing these arbitrary constants a and b. Now I take another example. Now we have the equation y is a e to the power 3x plus b e to the power minus 2x, and we have to form a differential equation by eliminating these arbitrary constants a and b. So just start differentiating. So dy over dx is a. Differentiation of e to the power 3x is 3e to the power 3x plus b is constant. Differentiation of e to the power minus 2x is minus 2e to the power 2x. This is done. Now I have to, since we are not able to differentiate it, then what you do, that we do it one more time, but before that I would like to simplify it. So this we can write as 3a e to the power 3x minus 2b e to the power 2x. This is dy by dx. Now differentiate this again. So d square y over dx square is becomes 9. 3 comes again. So 9a e to the power 3x. This also gives you minus this. Sorry, it's minus 2x minus 2x. So this will again give you minus. This become plus 4b e to the power minus 2x. So this is equation 1, this is equation 2, and now we have to remove the differential equation. So there is a rule from the determinants which we can do that says that we can differentiate, or if you don't like differentiation then we have to do it manually. So what do we do that? If you find this values of a and b, so we have two equation, one is this and other is this. So this equation I write first, second equation, that is d square y over dx square equals 9a e to the power 3x plus 4b e to the power minus 2x, and second equation. So if I multiply 2 in the second equation here, then you see this 2b will become 4b. So I multiply 2 here, so I get 2 dy by dx equals 6 a e to the power 3x minus 4b e to the power minus 2x. If you add these two, then these two cancel, and then you get 15a e to the power 3x as d square y over dx square plus 2 dy by dx. So your a e to the power 3x will be 1 over 15, that is d square y over dx square plus 2 dy by dx. Now we have to find this term, that is 4b e to the power this much. Means our normal dy by dx was dy over dx is 3a e to the power 3x minus 2b e to the power minus 2x, and this is fine. This is our normal second equation, which is d square y by dx square is 9a e to the power x. So this time I multiplied both sides of the equation, this by 2, and this one we didn't do anything with. This was our equation 1. So now I multiply this time, because this time I eliminated b by making 4b and minus 4b. This time I am going to eliminate this a by making it 9, because this is 9a and here we have 3. So what we do, that I multiply this equation by 3 and subtract it from the equation 1. So I write d square y by dx square is 9a e to the power 3x plus 4b e to the power minus 3x, and there I write 3 times this. So this is 3 dy by dx equal, this becomes 9a e to the power 3x minus 6b e to the power minus 2x. So if I subtract, I have to change the sign because I have to eliminate these two. This becomes plus. So this becomes d square y over dx square plus 3 dy by dx is, what is this? 6 plus 4, 4 plus 6 will become 10. 10b e to the power minus 2x. So these two are our main variables which help us to find the value of a and b. So here you see that what is my b? My b is, or I write here this e to the power 3x into a. So I get rid of this e to the power 3x from here. So this makes a better sense, that's a e to the power 3x, because it will be all together eliminated. Same way b e to the power minus 2x. b e to the power minus 2x is what? 1 by 10. 1 by 10, and this equation, which is d square y by dx square plus 3 dy by dx. Now we are almost done. So what we need, that I need to remove this part of the screen, and then I have to put the value of a e to the power 3x and b e to the power minus 2x in this equation, and then I'll simplify and we'll find that we'll have the equation where a and b both are eliminated. So now, so y, leave it as it is. A e to the power 3x, a e to the power 3x is 1 by 15, 1 by 15 d square y over dx square plus 2 dy by dx plus b, that is 1 by 10, 1 by 10 d square y by dx square plus 3 dy by dx. Now you see, in this equation we don't have any a or b. So these a and b's, both a and b have been eliminated from this equation, and now simplified equation of this form is your answer. So what I do, that I write directly here y 1 by 15, 1 by 10. So I write here d square y by dx square. If you take this common, you get 1 by 15 plus 1 by 10. I find what is 1 by 15 plus 1 by 10. So there, this is 1 by 15 plus 1 by 10, and this is 30. This is 2 plus 3, this is 5 by 30, or 1 by 6. So this is giving me 1 by 6. Plus here, go for dy by dx. So 2 by 15 plus 3 by 10. What is 2 by 15 plus 3 by 10? So 2 by 15 plus 3 by 10, LCM is 30, 15, 2, 4, 10, 3, 9, 13 by 20. This is giving me 13 by 30. I think I need to check it again. 1 by 15 d square y 1 by 10 is fine. So this is 2 by 15 plus 3 by 10. 2 by 15 plus 3 by 10, LCM is 30. 15 2s are 30, 2 2s are 4, 10 3s are 30. You might have seen that I made one silly mistake, that plus 3 is, this is minus 3, because we have subtracted equation 2 and from equation 1. Since I have already removed that part of the screen, you can't see this. So it means this part needs to be minus. So here 1 by 15, 2 by 15 minus 3 by 10. So 2 by 15 minus 3 by 10 is minus 5 by 30. Minus 5 by 30, that is minus 1 by 6. So this is minus 1 by 6 dy by dx. And then you cross multiply or simplify just to make it multiply it by 6. So this becomes d square y by dx square minus dy by dx equals 6y. So the formally finally it will become d square y by dx square minus dy by dx minus 6 equal to 0, and this is your final equation. Sometimes there is a method that is called the elimination of equation solving, like determinant method. Those who are very good in determinant, that can apply, but I simply use a normal method, and now just by watching this video is not going to help. You have to solve this equation. If you solve this equation, you will automatically find the solution for this, and that is how this equation can be solved. Thank you very much. Just subscribe to our channel and keep practicing with us.